All right, so today's going to be day one of us reviewing. We have this week and next week. Please don't be absent. And if you are, I will right now do my best to post the lesson, the review for every single class online on Google Classroom. Okay, make it a point to go over and make sure you do all of your quizzes, assignments. Every day, you're going to get about 4 or 5 of them. All review on whatever we covered that day. Okay. Mhm. All right, we're going to identify the parts of an expression. You should be able to look, find out, figure out what your variable is, your constant, your terms, your coefficients, and your factors. So when looking at this expression, and it's an expression because there is no equal sign, we have 32x squared minus 8x plus 4y minus 9. So if I ask you how many terms you have, terms are separated by plus and minuses. So we have 1, 2, 2, 3, and 4. So we have 4 terms. 32x squared is a term, negative 8x is a term, 4y is a term, and negative 9 is a term. If I ask you which ones are the variables, there's 2 types of variables here. We have x and we have y. If I ask you for the constants are the ones that have no variables to them. So the only term that doesn't have any variables is the negative 9. So our constant is negative 9. Factors of the first term. The first term is the one with the highest degree, or shall we say highest exponent. And in this case, it would be the x squared. So the coefficient, not asking for coefficients. The factors. Factors are things that we multiply. How do we break down the 32? Well, into factors. What are the factors of 32? Right, 32 is what, 8 times 4? And we can break down the 8 into 4 times 2, right? And those 4s, we can break them down into 2 times 2s. So there's a total of 1, 2, 3, 4, 5 2s. So the factors are 2 to the 5th times x times x. The 2 to the 5th is the, the 2 to the 5th is the 32, and the x times x is the x squared. So those are all the factors of the first term. All right, if you're wondering how we broke it down, we took the 32, we broke it down into 8 times 4. I broke down the 8 into 4 times 2, and then I further broke down the 4s into 2 times 2s. It's a total of 5 2s. Okay. All right, again, we need to identify the parts of this of 24x squared minus x minus 7. Go. Your terms are separated by plus or minuses, so that would be 24x squared, negative x, and negative 7. Okay? 3 terms. The constants is going to be the ones that don't have a variable. So the only term that doesn't have a variable is negative 7. The coefficients are going to be the numbers in front of the variables. So numbers front of variables. All right, this term has a variable. So the number in front is the 24. The middle term has a variable. The number in front is a negative 1. The last term doesn't have a variable, so that's not a coefficient. So those are the only coefficients. And the factors of the second term. Which one is the second term? The second term is this one. All right, the coefficient is a negative 1. So that's negative 1 times x. Right, negative x comes from negative 1 times x. There's only a single x this time. Okay. All right, classifying polynomials. In order to classify polynomials, the first thing is you need to be able to classify them by the degree. That's the highest exponent. All right, if it's just a number, which means no variable, it's a constant. If your variable is raised to the first power, it's linear. And of course, it's not always going to be x, but in this case, we're looking at it as x. We have x squared, if it's an exponent of 2, quadratic, cubic, exponent of 3. And then the second part of the name, or the last name, comes from the number of terms. And so if you only have one term, you're a monomial, two, binomial, trinomial, polynomial. All right, first name is degree. Looking at all these terms, which one has the highest degree? The middle term, right? So we're going to write that one first. Then looking at the other two terms, which one has the highest degree? The 3x or the minus 5x? Which one has the higher degree, highest exponent? What's the exponent on the x? 1. What's the exponent on this x? 1. They have the same exponent. They have the same degree. So we would consider these to be like terms, right? So because they're like terms, how do we combine 3x and minus 5x? All right, so using your calculator, what's 3 minus 5? Exactly. So this becomes negative 2x. All right, so first you need to simplify and write it in standard form in order to be able to name it. And so the first part is the largest exponent, which is a 2. So that would be quadratic. And the second part is the number of terms. How many terms do we have? 2 terms. So that would be binomial. Once again, if you don't simplify, you're going to get the wrong name. All right, the next one is just a 23. So you don't need to simplify it because there's only one term. What is the degree of a constant? Constants have a degree of 0. Degree of 0. So it's just constant. Right? And monomial, because you're only one term. But we don't normally call it a constant monomial because if you're a constant, right? So normally it just goes by constant. Want to try it again? Okay, so which term here has the highest exponents? 2x squared, and who else? Negative x squared, right? So because they have the same variables to the same exponents, they're like terms. So what is 2x squared minus x squared? 1x squared. Okay. Now, the two remaining ones, which one has the higher exponent? Focus. Out of these two, which one has the higher exponent? Right, the negative 2x. And then lastly, we'll write the constant. All right, so now you have to come up with the name. The highest exponent is 2. So from the list, what do you name something with degree 2? We don't know? Okay, good. We do know quadratic. And then the second part of the name comes from the number of terms, right? How many terms do you have and what is its name? Yes, we have 3 terms. And so it would be a trinomial, correct. Review, 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 okay? All right. This one, can you identify which term has the highest exponent? 2x to the third. Is there anybody else with x to the third? No, so it's by itself. Okay, we're done with that one. Next highest exponent. X squared, and nobody else has that one, so plus x squared. Okay. Next highest exponent. They have the same sign. So negative 4x and negative 3x. So same sign, you're going to add them and keep the sign. So use your calculators that you borrowed from me if you don't have your own. Come on. No, add the negative 4 and the negative 3. Negative 4 plus negative 3. Same sign. Negative 7, right? All right, there's like terms. Same sign, add the numbers, keep the sign. And then lastly, the constant, which is plus 1. All right, so now we've practiced this already. Determine the name of this polynomial by determining the first name and the last name. Okay. Okay. So what's the first name? Cubic. And what's the second name? It has 1, 2, 3, 4 terms. So it's going to be a polynomial. Right? Is it coming back? Is it coming back to you guys? All right. The next skill you need is to add, subtract polynomials. And so with this one, you need to be able to identify like terms. And you also need to be able to distribute negative signs. So we're going to get rid of parentheses first, right? If you have a subtraction, we need to change the sign of everything in the parentheses after the subtraction sign. And then we need to combine like terms, right? It's a ritual that we do every single time. So with this one, we have this set of parentheses plus this set of parentheses. But because there's a plus sign, all the signs are going to stay the same. So we could rewrite it, but we're not going to rewrite it because that's just going to, use up our time. So we're just going to find like terms. Starting with the highest exponents. Do you have something with the same like terms? Okay, and that 7 is negative. So using your calculator correctly, 3 plus negative 7. Negative 4. So it's going to become negative 4x squared. Okay. All right, what's the next highest exponent? Yes, but the 4x is negative and the 2x is positive. So in your calculator, you need to do negative 4 plus 2. Please don't yawn so loudly, okay? It is negative 2, so it can be negative 2x. Okay. And now lastly, the constants. So you have a positive 8 and a negative 5. So in your calculator, it'll be 8 plus a negative 5. Positive 3. All right, you got to be quick with that calculator. This is not just writing it down, it's also engaging in the solving process. You're going to get so much more out of it rather than just, oh, she wrote a 3, let me write down a 3. Okay. All right, so that's simplify. Now classify it. Go ahead and come up with the first name and the last name. So first we need to know the highest exponent, which is what? At 2. Correct. So what's the name when your exponent is 2 or your highest exponent is 2? Quadratic. And then the last name comes from the number of terms. How many terms you got? No, you have 3 terms. They're separated by pluses and minuses, right? So this is 1, this is 2, and that's 3. So yeah, you're right, trinomial. I heard binomial, right? So it's a quadratic trinomial. All right, so that was an example when you have a plus sign in between. This is the example, when we also have a plus sign in between. So this set of parentheses plus that set of parentheses. Plus sign, which means you don't have to change the signs. So what you need to do is find the terms with the highest exponents. There you go, and they're both positive, so in your calculator you would do 7 plus 5. So you have 12y squared. And notice what I'm doing, I'm underlining them, do this often. Then the next highest exponent, I have a positive 2y and a, so in your calculator you need to be careful, it's a positive 2 plus a negative 4. Negative 2, so it'd be negative 2y. Now lastly, the constants, being mindful of those signs. Negative 3 plus a 2, because a 2 is positive. So that's a negative 1. Right? All right, so now take a moment and classify it. That means name it using the naming scheme that we just reviewed in the second part. Find the first name and the last name. Okay, first name, quadratic because y squared is the highest exponent. Trinomial because we have 3 terms. All right, the next one is an example with a negative sign. Clear? We need to distribute that negative sign, and or when we do that, everybody inside is going to change signs, okay? So this is a case where you can either rewrite it or rewrite the second part. Clear? So I'm going to rewrite the second part. The first part's going to stay the same. So this is going to become negative 2x squared minus x and plus 6. The negative sign gets distributed. Everybody inside the parentheses changes signs. Any questions on that? This is what we do every time we have a negative sign and parentheses. Now we need to find our like terms just like before. Now we just repeat the process. Highest exponent. All right. In your calculator, 3 plus a negative 2. I get a positive 1. Right? So it's going to be 1x squared. Next highest exponents. Remember, you need to, yeah, this doesn't exist anymore. So in your calculator, you need to be very careful. So it's going to be negative 3 plus a negative 1. Because they're both negative. It's negative 4. All right, and lastly, you're going to do your constants, being mindful. So negative 5 plus 6. right? Naming this, how would you name it? Exactly, quadratic trinomial. Once again, when you have the minus sign, you need to distribute it to everybody in those parentheses. So now when you distribute, it's like you're multiplying by a -1. And if you really want to think about it the simple way, everybody changes signs. Positives become negatives, negatives become positives. I'm not going to rewrite the first part, but this one, you see how it used to be negative 2x squared? Now it becomes positive 2x squared. And last time, some of you guys got a little confused. So remember, that's no longer there. All right, combine your like terms and write down your simplified. Okay, 4x squared. All right, combining the 2x and the minus 5x. And then the -7 plus the -3. What do you get? Simplify it on your own. Let's go. Don't stop. Keep it moving. Let me know if you get the same thing or if you get something different. Did you get the same thing or did you get something different? 6x squared minus 3x. Okay, and that's it. That's all the only two terms you guys got? You guys want to look again at the problem? Huh? But I like that you're considering your constants, but it's not -4 because they're both negatives. So you got to put a plus sign in between them. -7 plus -3, -10. All right. Please don't be passive in the review. Please make sure that you're engaging, not just copying what's on the board. All right, you guys want to name this one? Quadratic trinomial. And you're like, why does it appear so much? Because we have an entire unit on just quadratics. Are we clear? All right, so with this one, if you don't have enough room, you can use the room on the left. Or if you need paper, I have some paper available. But what I don't want to hear is complaining about the lack of space. Take out a piece of paper and do it on a separate piece of paper then. All right, determine the values of m and n. And this really isn't a procedure, it's more number sense. And one of the things I notice is that the right side is simplified, but the left side is not simplified. You see? We have a plus sign there and we have sets of parentheses. Everybody see? So that means that we need to simplify the left with a little bit of understanding that m is a number, a constant, or in this case, a coefficient, and so is this -n, okay? So here we go. All right, which ones have x squared? So the ones that have x squared is the 2x squared and the mx squared. This is a plus sign, right? So that means no signs are going to change. So I have 2 plus m x squared. I guess I need to add the numbers in front. I don't know what m is, that's why I'm writing it like this. All right, that takes care of the x squared. Now we're going to do the ones that have the single x. That would be the 3x over here and the negative nx over here. Okay, so this is going to become 3 minus nx. And the constants are going to be nice to us. They're both constants. But one is negative and the other one is positive. So in your calculators, negative 8 plus 4. Negative 4. All right, and all of this equals this right here. I don't have any more room to write it, so I'm going to put the arrowhead, okay? Clear, clear? All right, do the constants match? Do we all see that the constants match? They're both negative 4. So that means that this right here, this 2 plus mx squared, has to be the 5x squared. Clear? Number sense, remember? So 2 plus m has to be equal to the 5. All right, so what do we have to do on both sides to solve for m? If I add 2, I'm not gonna get rid of this 2. I'm gonna create a 4. Subtract it, right? Now they're opposite signs, 0 pairs. Now they cancel. M equals 3. Now for the n, this is the one that comes with a single x. So this has to be equal to the negative 8, correct? So 3 minus n has to be equal to 8. So this is like going back to basics, basics, basics. So you're like, man, this is so easy now. But remember how much we were crying back then? All right, we're solving for n. So how do I get rid of the 3? Subtract from both sides. All right, because this 3 is positive up here. Okay. I'm going to carry down the negative n. 8 minus 3. Is that 5? But I have that negative n equals 5. Y'all see, y'all see? I don't want that negative sign. Right? Dividing by negative 1 gets rid of the negative sign. So n equals negative 5. Right, for this one, I'm going to use paper. Now, what's the difference between example E and example F? Example E has a plus sign, whereas example F has a minus sign, which means we need to distribute that negative sign. So I'm going to work on the paper. I can see it, so I have mx squared minus 6x plus 3 and then it says minus. You might need additional paper because this one is And it's the same type of problem, right? This one is already simplified, but this side over here needs to be simplified. But it's not that simple because of this negative sign, right? And when we distribute that negative sign, everybody's going to change signs. I just rewrote those three terms. So it's going to have minus 4x squared minus nx, and then this minus 4 is going to become plus 4. And of course, it still equals this over here on the right-hand side, but right now we're simplifying this. Now, which ones have the highest exponent? So this becomes m minus 4 x squared then let's see, squiggly and squiggly. Ooh, Lord, they're both negatives. You see that? And I already put my plus sign here. So I have to write this one as negative 6 minus n x plus, and I'm being careful on these problems because I know it takes a little bit longer, okay? And then the constants. And the good thing is they're both positive, see? And what's 3 plus 4? 7. All right, so this should equal negative 2x squared minus 3x plus 7. Look, constants are equal, right? That means that our m minus 4 should be equal to what? Negative 2? Correct. So, all right, so we're going to do side calculations now. Here we go. M minus 4 should be equal to negative 2. And the negative 6, negative n should be equal to the negative 3. Right? Because they're the ones, that's the coefficient in front of the x. And that's the coefficient in front of the x. Right? Wow, one page, all this work. But I'm spending time on this because when we start going through this in the other units, we're not going to go this slow in simplifying. Are we clear? Okay, just so that you understand. All right, so that means m is going to be equal to 2. And then this one, first I'm going to move the negative 6. And then because I have a negative sign here, I'm going to swap it around. Here we go. It's basically the same thing as dividing by negative 1, okay? All right, flip the page. Those of you that are done writing. All right, multiplying polynomials. Remember the area model? Set up the area model, combine like terms. We can also use a distributive model, but let's talk about multiplying. When we multiply the basis, multiply the coefficients. Right? And we add exponents. Of course, in the same base, right? If it's the same variable, we add the exponents. We multiply the coefficients, we add the exponents when we're multiplying. Remember, when we're adding and subtracting, we don't touch the exponents. The exponents stay the same, but when we're multiplying, we got to add the exponents. That is why x times x is equal to x squared, because they both have a 1. 1 plus 1 is 2. Versus x plus x, that's just 2x. First problem, find this product. All right, x 5. I really only worry if it's negative, okay? And now we do our thing. What's x times x? And no matter where you go, you just got to make sure you multiply correctly. X times negative 2 is negative 2x. 5 times x is 5x. And then this 5 is positive, but the negative 2 is negative. So 5 times negative 2 is negative 10. And did you end up with any of them that are like terms? Exactly. But remember, we got to add them. That's what this little plus sign in the center is supposed to remind you. So what's 5 plus a negative 2? Okay. It should be 3. All right, so your final answer will be x squared plus 3x minus 10. All right, this one. What does the square means? The square means that you're multiplying this by itself. So it becomes x minus 5 times x minus 5. So x negative 5, x negative 5. All right, what is x times x? Beautiful. What is negative 5 times x? Same thing here. Even though we start with the x, x times a negative 5 is negative 5x. Now over here is where you have to be very careful with your integers, okay? Negative 5 times negative 5. No, we're multiplying them. All right, come on, we all have calculators. Negative 5 times negative 5. Exactly, a positive 25, okay? And now we end up with the same situation where we have like terms. And please don't make assumptions. Please, 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 on the milestone. There's only so many questions that they can ask you, so most questions will not be repeated. It's a one-time deal. So I suggest that you use the calculator. What is negative 5 plus negative 5? Beautiful, negative 10. So this becomes x squared minus 10x plus 25. I know this sounds like really horrible advice, but please don't be brave on the milestone. Use the calculator. Use the calculator for this is the time when you have to use the calculator for the simple calculations. Are we clear? Because usually that's where we mess up most of the times. Okay, so we want to get rid of that. It's like you can do the hardest problems, but then when it comes to negative 5 times negative 5, you're like, negative 25. Nope, it's not. It's positive 25. Okay, product means multiply. All right, and so once again, we set up box 2x, negative 4, 3x, 3. Okay, start multiplying. Don't just copy, multiply. really hope that when they're testing you on these standards, that you do it well, you do it carefully, okay? If you have scratch paper, please use scratch paper, aided by Desmos, okay? Or a handheld calculator. Okay. Are we ready to multiply together? Now with this one, we're just gonna multiply the coefficients. What's 2 times 3? And then the x times the x will give us x squared, okay? Good if you get that one right. Now this one, the 2x times the 3 will just give you 6x though, single x. This one's a -4 and that's a +3, so that's -12x. Don't forget about the variable. So now these don't have variables, but one is negative and the other one is positive. This will be -12. And remember what I said, this is not the time to be brave. Use that calculator when you're combining these two terms. All right, I helped you with the first term. What's the middle term? I'll also help you with the last term. What's the middle term? You got to combine those two terms. Negative what? When you're combining like terms, you're adding them. So this intersection right here looks like a plus sign. Use that to remind yourself that you need to add those coefficients. -6x. Okay. Remember, after you fill in the 4 boxes, you are done multiplying. After that, it's just combining like terms. Questions? All right, this one, did you fill in the boxes? Go ahead and multiply. All right, can I fill them in? We're good? Everybody had an opportunity? Okay, x squared, okay, minus 3x, and -9. Okay. All right, so we're done multiplying. Once you fill in the boxes, we're done multiplying. Now you have to combine like terms. Combining means that you're adding the coefficients of like terms. I'll help you out with the first term. Ooh, there. Okay. Now using your calculator, -6x. Correct. And then I'll help you with the last term. No, no, no. Yes, I will. That's okay. I'll do it. Here we go. -9. Beautiful. See? Teamwork. What happened? Oh, well, at the end of class when we're done. It's also it will be on video, okay? So don't stress over it so much. All right, now the applications. Everybody's. This is the whole point. They're not probably not going to ask you something as simple as just multiply. Maybe they will, but then they'll also give it to you in application form. Most definitely will. Okay. Perimeter. Fill in all the missing sides. Please, please remember that. And then add all the sides on the exterior of the figure. So if I wanted to do the perimeter for this one, what's the first thing I need to do? Missing side. So how much is this side that's blank right here? It is not 2. Nope, it is the same as this one. So this one is also? Why? Because it's a rectangle. Opposite sides are equal in a rectangle, okay? Now we also have to fill in this missing side. How much is this missing side? 2x minus 4. Okay? So for the perimeter, you need to add all the sides. All right, go ahead and circle that. Add all the sides for polynomial. That means add all your like terms. So in looking at these four sides, which ones are like terms? X, 2x, x, and 2x. Are we clear? They all have a single x? So now add all of those numbers. So what's the number here in front of this x? Nobody says anything. 1, beautiful. I didn't hear you though. Okay, so 1. Okay, so add up all your coefficients on the x's. All right, so how many do we get? Hmm? It should be 6, right? Because 2 plus 2 is 4, and then 5 and then 6. So it should be 6x. Now add the constants. Uh, it is not 20. Please use a plus sign in between those numbers. Yeah. Yeah, you do 6 plus 6, and then minus 4, minus 4. Okay? Or plus a negative 4, plus a negative 4. 6 plus 6 plus a negative 4 plus a negative 4. Okay? So yeah, positive 4. And that is the perimeter. Now for the area. For the area, we got to use the area formula for the respective figure. Since this is a rectangle, it's going to be the length times the width. Right? If it was a triangle, it would be the base times the height divided by 2. And then we use the area model to multiply if necessary. So we're going to call this one the length, and we're going to call this one the width. Any questions on that? All right, my area model. The length is 2x minus 4, and the width is x plus 6. Oops, sorry, I didn't mean to put the plus sign, but it doesn't matter. Okay, so go ahead and fill in the boxes by multiplying. Please engage. Don't do something else. Focus. All right, remember, we're reviewing the basics so that in the future chapters, unit reviews, we won't be focusing so much on the basics as the new skills, okay? All right. Somebody's playing their music very, very, very loud. There we go. Thank you. It wasn't him. It was from over here. All right, can I start filling in the boxes? Good. All right, so what is 2x times x? Mm-hmm. What is negative 4 times x? Mm-hmm. What is 2x times 6? Mm-hmm. And negative 4 times 6. All right, you are done multiplying. Now all you have to do is combine like terms, if any, which most of the times you will have like terms. Okay, combining like terms means that you're going to use the fact that this grid makes a little plus sign in the middle to remind you that you're adding the coefficients. All right, once again, I'll help you out with the first term. Oof. Okay, all the hard work is done. Now combine the middle terms. Combine it correctly with that calculator. Let's go. Okay. So plus 8x and then minus 24. Okay, so this is an example of perimeter, an example of area. Now, the milestone's favorite problem. Are we clear? It's the favorite problem because it incorporates everything that we just done all in one big fat problem. We want the area of only the shaded region. If I calculate the area of this giant block, I get the area that I want plus this middle section that I don't want. If I only calculate the area of the middle block of the one inside, then I don't get the shaded area. I only get that white block in the middle that I don't want, okay? So the technique for doing this is you're going to calculate the area of the entire big block, and then we're going to subtract the area of the white block. Clear? That's going to give us only the shaded area. So it's going to be the area of the big block minus the area of the inside block. And that's going to give us the shaded area. So it is like 4 problems in one. Time for outside paper help. All right, area of the big block. All right. All right, so do we agree that the big block has a length of 4x plus 2? And a height, I'm sorry, and a width of 4x plus 2? Yes? There we go. All right, please keep up, do the calculations, do your own multiplications. These are elementary school math facts. Come on, people. Yeah, 4 times 4 is elementary school. Yes, 4 times 4 is 16, and x times x is x squared. Okay? Okay, this block right here, 4x times 2. Now this block is 2 times 4x. All right, and then the last one, this one is definitely middle school, 2 times 2. There we go. All right, you are done multiplying. You are now combining like terms. And you're going to use the fact that this grid makes a little plus sign here to remind you what you're doing to those coefficients. All right, so the area of the big block should be, Miss Patrick, 8 plus 8. That's still middle school. Okay. Are we done? No. That's just this part right here, the area of the big block. Okay. Now we need to do the area of the inside block, okay? Okay. One is, oh, they're both x minus 1, see? It's not just a rectangle, it's squares. But we can treat it as rectangles. Squares are a special case of rectangles. All right, negative signs. So we're going to be careful on this. X times x is just going to be, now this becomes negative x, and so does this one. But for the last block, it's negative 1 times a negative 1. And negative times negative make a positive, so this becomes a positive 1. Same deal. Box is reminding you that you are adding the coefficients. So it's negative 1 plus negative 1 here. Okay. Oh. So I'll help you with the first block, x squared. And what's negative 1 plus negative 1? There you go, negative 2x, correct. And then just plus 1. All right. Y'all still alive? Okay, well, good. Here we go. I'm glad you're still alive. For those of you that said no, I don't have a response for you. So now we need to do the area of the big block and subtract the area of the inside block so that we can get the shaded area, okay? So I'm still on paper. Unlike you guys, I have a nice batch of paper, so here I go. All right, area of the big block. Subtract. Y'all see my subtraction sign there? Area of the smaller block, which is this one. All right, area of the big block, and I'm going to subtract the area of the small block, and that's going to give me the answer. Now this became it went from being a multiplication problem to now a subtraction problem. See why milestones love this problem? But we're ready for this. What happens because of this minus sign? Correct, they're going to change signs. Correct. And since I've been doing a lot of writing, I'm not going to rewrite these, but I'm only going to rewrite over here. Minus x squared, and then this one's going to become plus 2x, and this is going to become, there we go. And so that I don't get confused, okay. All right, so now do your thing, like terms. 16 add negative 1. 16 add a negative 1. Okay. Now this is a 16 add a positive 2. So what's 16 add 2? So plus 18x. And then the constants. 4 add negative 1. exactly 3. And this is the area of the shaded region. All right, let's skip a bit. Can you all flip the page and go to rational, irrational numbers? Ooh, 11:40. All right, let's stop here for today, second period. I'll post all 3 classes, clear? And if I go further in the other classes, please make sure that you watch the videos and I'll let you know because it is a lot to cover and this is just the first unit. You see why we need 2 weeks? Thank you. You guys are awesome today. I really appreciate it. Those of you that were paying attention, it was very nice. The rest of you guys, I appreciate it as well.